All right, in this video, we're going to talk about 3.5 Objective 7, where we solve applications involving derivatives of trigonometric functions. An object oscillates along a line, and its displacement in centimeters is given by the function y of t is equal to 35 times sine of t minus 1 in parentheses, with the 35 on the outside, where t is greater than or equal to 0, meaning probably that t represents time. Yep. T greater than or equal to 0 is measured in seconds, and y is positive in the upward direction, right? So graph the position function for 0 to 10 seconds here. Just stick that in your calculator, what this function looks like. It's going to look like d. I'm not going to pull out my calculator and graph that. Make sure that you are using some intuition here to figure out how big your window needs to be to try and figure out where this low point is, that this is not going to be low enough. So you need a bigger window here that's going to go down to -75. So your velocity function is the derivative of your position function. So let's figure out first what that's going to be. So the derivative of sine of t minus 1 is going to be cosine of t. So this is going to be 35 cosine of t. And then we can graph that in our calculator. And that is going to look like b. Starts at a maximum and goes down to a 0, down to a minimum, up to a 0, up to a maximum, and so on, like that. And then what would the zeros of the velocity function be? So they're going to be here at these places between these minimum and maximum points. So they're at pi over 2, 3 pi over 2, 5 pi over 2, so on, right? So and then what are the positions when that happens? You have to stick that into the position function up here to figure out what the positions are at those at those times. And you can do that with your calculator as well, but that's where the 0 and the -70 and the 0 and so on are coming from. But the at what time what are the times and positions that the velocity is at a maximum? Okay, so that's going to be, maximums are right here and here, and then again, so every 2 pi, right, starting at 0. So 0, 2 pi, 4 pi, so on. So that's b. And then these are their corresponding y values. Then the second derivative, the acceleration of the oscillation, is going to be what? And it's going to look like what? So that's going to be a -35 sine of t. So a sine function starts at 0, but it's going to open down like so. So that's going to be c, like that. And that's it for this video. Just able to graph these types of functions. This one was a sine function that had been stretched and shifted a little bit. Just encourage you to put that into your calculator for the first one. But this one was pretty straightforward, that it was a cosine function that had been stretched. And then this one was a pretty standard sine function that had been reflected and stretched as well. All right. Again, that's it for this video. We'll come back next time and talk about 3.5 Objective 8, where we solve questions involving tangent lines of trigonometric functions. See you for the next video.